Let's look at more examples for the exponential distribution. Okay, so imagine this situation. We're trying to see how long somebody's on the phone. Okay, so basically we take 100 samples over the course of the month and we measure the length of the phone calls in minutes. And here's the data you can imagine. So one phone call just had 0 minutes, okay, and then one was 0.1 of a minute long and so forth. Okay, so 100 different examples of how long phone conversations can be. When these data points were plotted, they gave us this shape. This is the exponential shape. Okay, we expect this to be exponential shape. If we're talking about how long does a phone call last, basically you're talking about length of time per phone call, okay, so time per success. This should be an exponential type question. Okay, so you can see that it's exponential shaped, it's skewed to the right. The average of these 100, so if I added up all 100 of these data points and divided by 100, gave me 3.6. So what I'm saying here is x, the amount of time for a call in minutes, is exponentially distributed with beta, the expected number of the expected length of a call being 3.6 minutes. Okay, so x is exponentially distributed with beta being 3.6 minutes per call. Okay, we can use this to answer any number of questions. Okay, the following exponential distribution was given. What's the probability that a call made will be at most 3 minutes? So here, when you're thinking about at most 3 minutes, ask yourself, is 3 allowed when you say at most 3 minutes? Yes. Is less than 3 minutes allowed? At most 3 minutes? Yes, that's allowed as well. What about more than 3 minutes? Is 4 minutes allowed? No. Okay, so at most really means less than or equal to 3 minutes. Okay, so really what I'm looking for is this is the probability that a call will last less than or equal to 3 minutes. You can use your formula. Okay, x is this value 3, and beta is the amount of minutes per call on average. And so you could use this formula. You can also use Minitab to go calc, probability distribution, exponential. Here I'm saying the average call lasts 3.6 minutes. I want the less than or equal to the probability that a call lasts less than 3 minutes. And here I get the chance that a call will last less than 3 minutes is about 56 or 57-ish% of the time. What is the probability that a call made will last between 2 and 4 minutes long? Okay, so what's that chance? Here you go. Basically, you're saying x, the length of a call, is in between 2 minutes and 4.5 minutes. You can just use the same tricks that we were using before. Okay, you could use the cumulative to find all the way to 4.5 minutes. You can also find the probability of it just lasting 2 minutes. If we take the subtraction of these two, we will get strictly in between 2 and 4.5 minutes. Okay, using the formula, you can just sub it into your formula like that, and you can do some cancellation and find this answer out. Okay, also with Minitab, we can say something like, I want 4.5 minutes. I also want to find the cumulative 4.5 and the cumulative 2. In Minitab, I could go to probability distributions, the exponential distribution here. My average call was 3.6 minutes, and in the input constant, I'm going to say, well, can you find me both of these cumulative calls here? I could store it in column 2 and right next to these values. Okay, here are the cumulative probabilities. If I take 71 and subtract 42, I'm going to get somewhere around 28. Okay, so that's the probability that a call will last in between 2 and 4.5 minutes long. Notice that I don't use the memory list property here. Memory list property is only for conditions. I'm not saying given that a call lasted 4.5 minutes, or given that a call lasted 2 minutes, what's the probability it'll last 4.5 minutes? If that was the case, I could use the memory list property, just find the difference of 4.5 and 2, which would be 2.5, and then just find the probability of a call lasting less than or equal to 2.5 minutes. I'm not asking that. Okay, I'm not saying given that it has lasted 2. I'm just saying before the call even happens, what's the chance that that call will last in between 2 and 4.5 minutes? Okay, so here we can do another interesting version of this. 10% of all the calls made to this service center will exceed how many minutes? Okay, so the top 10% of the calls, how long are they? Basically is what this question's asking. Let me try and draw this with a picture. Okay, so the exponential curve will look something like this. If this area is 10% of the top 10%, that means the bottom 90%. I'm splitting this up into 10% and 90%. You could do some calculation here. You could say that you could set 0.1, the top 10%, is equal to x is greater than x, and then solve for x using some logarithms. But Minitab does this as well. Okay, so here what I need to see is when I have the area, okay, so this is the area that's known, and I'm looking for the value. We've never done a question like this yet. What I need to do is go to Calc, Probability Distribution, still the exponential distribution. When I had the value here and wanted the area, I've been using cumulative probability. But here I have the area and I want the value. So I will select inverse cumulative probability. The average length of a call is still 3.6 minutes. And here the inverse cumulative probability, what I need to do, Minitab only ever knows the less than or equal to sign. So what I need to do is tell it that the cumulative area from the start to my point is 90%, 0.9. Okay, we don't want to say 0.1 because that'll just do here 0.1 and it'll find the value somewhere around here. We want to have the cumulative probability, so from the start to this point. Okay, so you need to know if you're talking about the top percent or the bottom percent, because Minitab only takes the bottom percentage. Okay, so here we can solve it. It says if 90% of the time calls will last less than 8.3 minutes-ish. Okay, another way of saying this is the top 10% of calls will last longer than 8.3 minutes. Okay, so that's what I'm saying here. 10% of the calls, the top 10% of the calls will last longer than 8.3 minutes.